Okay, Honors Math 11, we are doing related rates, and these are all word problems. Keep in mind, I am going to upload the paper notes that correspond to this. So it might be useful if you have the paper notes in front of you as I'm going through the problem, or watch this, then look at the paper notes, whatever helps. There's no specific formula for each one. The formula depends on the figure that is drawn. And what the question is asking. So for this first word problem, it says an airplane is on a flight path that will take it over a radar station. Now, I didn't write it because I don't have enough board space. If I had more board space, I'd probably write the plane is on a flight path that is parallel to the ground. That's how most planes fly. But you need to assume that that airplane is flying parallel to the ground. So an airplane is on a flight path that will take it over a radar station. It's not over it yet. It will eventually take it over a radar station. If the distance from the plane to the radar station is decreasing at a rate of 400 miles per hour, so you have to keep in mind all of these rates of change are with respect to time, all right, miles per hour. And the height of the plane is 6 miles, find the speed of the airplane when it's 10 miles from the radar station. I think in a lot of cases, the hardest part is to figure out what does my drawing look like. Okay, so first thing we're gonna do is draw the ground and our radar station. We're gonna call it R. All right, the airplane is flying parallel to the ground and it's going to pass over the radar station, but is not over it. So I'm gonna put the airplane here. There's A, and it is traveling parallel to the ground. All right, so it says an airplane is on a path that will take it over the radar station. The distance, all right, D, from the plane to the radar station. So stop, who cares about the information? The distance from the airplane to the radar station. There's D, there's your distance. All right, the direct distance from the airplane to the radar station. I could have called that P too. I don't know if that's confusing, A, P. So anyway, so there's your distance. All right, it is decreasing at a rate of 400 miles per hour. We'll come back to that after. And the height of the plane is 6 miles. So I can draw the height here and here. Doesn't matter where you draw the height. So the height of the airplane right here is 6 miles. I can also draw the height over here. All right, either way. So this is also perpendicular. So what you need to recognize here is that you have a right triangle. That is the figure that is involved in this particular problem. Now the distance right here from the airplane to the radar station, this is going to be your speed. So if we call this distance X, the change in that distance with respect to time, the change in X with respect to time is the speed of the airplane. All right, so here's what you need to do. You need to set up the Pythagorean theorem using X, 6, and D. So you know that X squared plus 6 squared is equal to D squared. So before you do anything, you're going to take the first derivative with respect to time. So the first derivative is going to be with respect to time. So something, d something dt. So if we take the derivative of x squared, this becomes 2x, and we're taking the derivative of x with respect to time. So you're going to have to write dx dt. So the change in x with respect to time. Plus, now take the derivative of 6 squared. You know that's 36, and you also know the first derivative of any constant is 0. So plus 0, and that equals, now we're going to take the derivative of d with respect to time. So the first derivative of d squared is 2d, and we're taking the derivative of d with respect to time, so we have to write dd, the derivative of d, with respect to time. So here's your new equation. You have 2x dx dt equals 2d dd dt. So there's your formula. So now I'm running out of board space. So I want you to keep this picture in mind, and keep in mind also that we are trying to find the speed, the change in x with respect to time. So dx dt, this is actually what we're solving for. All right, so the next step in these related rates problems is to always take your first derivative with respect to time. And now let's list every single variable that is in this equation right here. There are 4 of them. All right, so the first variable is just x. The second variable is dx dt. The third variable is d. And the fourth variable is d dt. All right, so let's figure out what we know and what we're solving for. You know dx dt, that's the speed of the airplane. That's ultimately what we're going to be solving for. Okay, so now in order to find x, go back to the picture. I'm so sorry I erased it here. Go back to your picture. This was x, this was 6, the height of the plane, and then we had d, the distance the airplane was from the radar station. Now, if you go back to your word problem, all right, let's fill a few things in. It says that the plane, the distance, all right, the plane is from the radar station is decreasing at a rate of 400 miles per hour. So this distance is decreasing. So d dt is decreasing at a rate of 400 miles per hour. So since it's decreasing, it's negative 400. All right, d, they want to know what's the speed of the airplane when the distance from the airplane to the radar station is 10. So we're going to let d be 10. Now, if we let d be 10, can't we do Pythagorean theorem to find the value of x? So you would get x squared plus 6 squared equals 10 squared. And I'm hoping that you guys recognize that this is a 3, 4, 5 right triangle, so 6, 8, 10. If you do the Pythagorean theorem, you will find that x has a value of 8. So when the plane is 6 miles in the air, 10 miles from the radar station, its ground distance will be 8 miles. All right, so you have everything you need to solve this. We can now plug in all of our variables. So 2 times x, which is 8, dx dt, equals 2 times d, which we know is 10, times negative 400. So if we get dx dt all by itself on one side, if you solve for this, again, I apologize, I have to erase here. You get 16 dx dt equals 2 times 10 times negative 400 is negative 8,000. And if you divide both sides by 16, you get the change in x with respect to time, or the speed of the airplane is going to be negative 500 miles per hour, but you have to take the absolute value of that. So it's just 500 miles per hour because it was the distance was decreasing. So is the ground distance. The ground distance is decreasing, but you never use negative for a speed. You take the absolute value, and there's the speed of the airplane.